All right, today we're unpacking a really fascinating and highly detailed fictional blueprint for a faster-than-light drive. We're talking about a design that claims it can make interstellar travel not just, possible, but literally instantaneous. The dream of traveling to the stars has always smashed right into one big, insurmountable wall: physics. The distances are just, well, they're staggering. Our closest stellar neighbor, Proxima Centauri, is over 4 light years away. With the tech we have now, you'd be looking at a journey of tens of thousands of years. But this concept, the inflationary entanglement resonator, or IER for short, it proposes a totally radical new path. And the brilliant part is, it doesn't try to break the rules of physics. Nope. Instead, it finds a super clever loophole, one that was forged in the very first moments of the universe. So yeah, let's dive into this. Okay, first things first. To really get why this idea is such a breakthrough, we have to understand the core problem. I mean, why have things like warp drives and wormholes stayed firmly in the realm of sci-fi? Well, it all boils down to one simple, brutal fact: the energy cost. So you look at previous ideas, like the famous Alcubierre warp drive. They require absolutely astronomical amounts of this theoretical exotic matter with negative energy. And we're not talking a little bit here. We're talking about taking the entire mass of Jupiter and converting it into this stuff, just to get the engine started. The IIR drive, on the other hand, operates on an energy scale we can actually imagine building. And this table, man, it really puts those numbers into perspective. A Morse Thorn wormhole, you'd need the exotic matter equivalent of 7 suns. 7! Even a souped-up optimized Alcubierre drive needs a dwarf planet's worth. These aren't engineering challenges, folks. These are cosmic impossibilities. It's just fundamentally beyond our reach. In fact, our best shot in real-world physics at creating this negative energy, something called the Casimir effect, it falls short by about 38 orders of magnitude. To put that in perspective, that's kind of like trying to pay for the entire world's economy with a single atom. It wasn't just a gap, it was a chasm that looked absolutely impossible to cross. So how in the world does the IER solve this? Well, here's the beautiful part. It doesn't even try to cross that chasm. Instead, it finds a bridge that's already there, a pre-existing shortcut that was forged in the first moments of the universe and has just been sitting there waiting for us to figure it out. Now, the theoretical key comes from this mind-bending idea in modern physics called ER-EPR. It basically suggests that quantum entanglement, that spooky action at a distance Einstein was so famously bothered by, isn't just some weird statistical trick. No, it's a literal, physical, geometric connection through space-time. It's a tiny, microscopic wormhole. And this just brilliantly lays out the IIR's core logic. The universe already did all the heavy lifting. The Big Bang created this huge cosmic web of entanglement that connects pretty much everything. So that means the universe is already crisscrossed with these little wormholes. The drive doesn't need the energy of Jupiter to build a bridge. It just needs the energy of a single photon to essentially open a gate that's already there. Okay. But how do you open one specific quantum wormhole that just so happens to connect you to a star 4 light years away? Well, the blueprint's answer is surprisingly elegant, and it draws on a principle we can actually see right here on Earth: the physics of sound waves. This right here is the secret sauce. So, on the left, you've got cymatics. That's when you use synchronized vibrations to make these beautiful, stable geometric patterns in sand. And on the right, the EIR drive. The blueprint argues that the principle is exactly the same. You use perfectly synchronized vibrations to create a stable, geometric point of super high energy. And get this isn't just some helpful analogy. The blueprint says it's a universal scaling principle. It doesn't matter if it's sound waves making a pattern in a lab, or the IER's plasma emitters creating a wormhole throat. The underlying math is identical. The drive basically plays a chord in space-time, and when that harmony is absolutely perfect, the door just opens. But opening the door, well, that's only half the battle. And this is where this fictional design gets really, really ingenious. Because going through that jump means experiencing forces that are just unimaginable. How could any person, or any ship for that matter, possibly survive it? So an unprotected jump would slam the crew with accelerations of a quadrillion Gs. A quadrillion. That's not just fatal, that's instant, complete disintegration. The solution is this incredible piece of engineering detailed in the plans, and it's called the Matryoshka shield. Think of it like a set of those Russian nesting dolls. But instead of simple dolls, they're incredibly complex, high-speed gyroscopes. The crew sits in a totally stationary core right in the middle, while each shell spins faster than the one outside it. This whole setup creates a multi-layered, dynamic buffer against the incredibly violent transition of the outside universe. And this system works in two amazing ways at once. First, thanks to Einstein's general relativity, the spinning shells literally drag space-time along with them. This dilates time and cuts down the felt g-forces by a factor of 1,000,000. Second, the pure gyroscopic action mechanically cancels out another millionfold in forces. So you put it all together, and the total effect reduces a fatal 1 quadrillion Gs to a strenuous, but totally survivable 10 to 20 Gs. So let's put it all together. With the energy problem, the mechanism, and the survival problem solved, at least on paper, what does the final ship, the IER-1 Pathfinder, actually look like? Here are the specs. It's a pretty compact vessel, designed for a crew of 4, with what is essentially an unlimited, instantaneous range. And check out this detail. The jump itself takes mere nanoseconds from an outside perspective. But because of the shield's crazy time warping effects, the crew inside only perceives a fraction of a second. The blueprint doesn't just stop there. It even lays out a pretty plausible step-by-step development timeline. It moves from validating the core physics in the near future, all the way up to robotic missions by 2040, and then finally crewed interstellar missions by the middle of the century. So in the end, yeah, the IER-1 is a work of fiction. But here's the thing, every single piece of it is built on a foundation of real, cutting-edge physics, from general relativity to quantum entanglement. It really serves as this powerful thought experiment, pushing all of us to ask, what else might be achievable? Not by breaking the laws of nature, but by just understanding them more deeply than we ever have before.